Welcome once again to Automate with Kaj, your way simplify industrial automation. On today's episode, you and I will write together your first program for Modbus TCP Master on the Control Edge Builder. Remember in last episode, I showed you how to use the Control Edge Builder software for programming, whether it is the Control Edge 2020 RTU, the Control Edge 900 HCPLC, or the non-redundant and the redundant controller. So today we're going to configure the PLC or the RTU to serve as a Modbus TCP master. So grab your writing materials and your computer and let's get started. So we start by opening the Control Edge Builder software. This is how the interface would look like when you open it. Alright, so for our project today, we'll be creating a new project. Alright, you can do that just like I explained in the other tutorial by selecting the create project or by clicking the create project button, or on this toolbar up here, you click on File, New Project. Okay, so for our case, let's create project. Now the new pop-up window that comes gives us the option to create new project from templates, and the four available templates are the 900 CP1 for the 900 controller, and it applies to both redundant and non-redundant controller application. We have the SCUCMX01, SCUCMX02 also, which are non-redundant controllers, and you have the SCUCNN11, which is a redundant controller. Our controller of interest is the SCUCMX02 non-redundant controller. You can select the controller that applies to you. You click on next and we'll give our project a name. You can give it any name you want. For our case, I'll be calling it Modbus TCP. So click on save. Yeah, to replace the existing one there. Click yes. And a new project to be created for us. Once this project creation is complete, a new window will appear. So now this is the window for our project. Right, as you can see, project name Modbus TCP. I've given us a walkthrough on this interface. If you don't know it, please check the previous video in this tutorial. So first of all, we'll do is set controller name. So if you're doing this for a specific site, you need to give this name of the site. Okay, so that another person who sees this program will know that, oh, this is for, this is the backup program for that specific site. For our case, we just give it the name Modbus TCP Master. You click save. Now, if you notice down here, you're seeing some text moving. All right. So as you create a new project, it automatically does a compilation, okay, to more of prepare these projects for download. Okay, if we download it like this, it will just download the default setting into the controller, default setting without any program, just the regular POU. Okay, just the default POU. So everything is the default setting, empty. So that's what you're seeing happening under there. Okay, so let's continue with our configuration. We'll give a configure controller startup, and this will set it as running. As operating mode running after abnormal stop. We'll click OK. Sorry about that. Click OK. Then next is we configure Ethernet ports. we have two Ethernet ports on the controller. We have Ethernet port 1 and Ethernet port 2. For this specific controller, we only have only two Ethernet ports. So we select Ethernet port 1. I would say there's already a default IP address 169.254.203.118. You can leave it this way, alright, or you can choose to change it depending on the setting on your site. So I'll give it any IP address of my choice. I can call it 192.168 rather dot 168 dot just say dot 10.2. Okay, I'll give it a subnet, the side annotation of /24, and then for protocol binding, bind it as what a Modbus TCP master. So we're going to use this port, Ethernet port 1. Please take note of this, Ethernet port 1 as our port for communication from Modbus TCP master. So after this, you save. Make sure you save. If you don't save, this setting will disappear. Okay, I'll go to port 2. We can choose to leave this, or you can set it depending on your application. So I'll just call this port 3. Set it as Modbus slave. You can set it as a master or whatever protocol you want to set it as. Click on save. Okay, so that's for this. You can exit this window by pressing this back button. Okay, and that is all for this page. Okay, on upcoming tutorials, especially configuring for slave, we'll use this IO communication, but for now, this is where we'll focus on. So the next thing is program with IEC 611.3.1.3. I explained what this is. We can go to that page by clicking here, program with this button here, or over here, IEC programming workspace. So whichever one we click on, it will take us to the programming workspace. So the next on our agenda is now we have a blank page. Okay, we don't have any program running here. So we're going to set this up to carry out Modbus communication. We're going to do it step by step. So the first thing we're going to look at is libraries. So we need to add the library for Modbus communication. All right, Honeywell have two different libraries. You right click on libraries, hover on insert, and you see user library and firmware library. Interest is firmware library. Firmware library, and you can just type, either you search for it, Modbus, as you can see here, you can just type it Modbus and click on include, and you select modbus.fwl, and that library will be inserted into your program. So once that is done, the next thing you should do is data types. You need to create a data type. All right. Now, depending on what Modbus application you want to run, sometimes you might want to read multiple data. Okay, maybe 10, 10, 10 data points, 20 data points. All right, Modbus gives us the ability to read that total number of points or even more. Okay. So we have to, for Honeywell, we have to create data types where this data will be stored so that we can be able to assign them to their corresponding variables, okay, variable names. So let's create the data type, right click, insert, data types. So we'll call this, just call this Modbus setting, okay, or let me call it Modbus storage, Modbus data storage. Click OK. So now we need to define the variable. So we double click on it, okay, and then we write this type, give it a name. Let's call it data output. We'll give it the data type array, the total number of data points you want to do. So let's imagine you want to do 50. You want to store 50 data points. So I 50 of real. Okay, so you can do unsigned ints, real, long real, different data types, and then end type. All right, so when you're done, you save and then you compile. Now, the reason for compiling is so that this data type can now be added on the list of variables in the global under global variables. All right, as you can see, as you've done this, you can see all these asterisks here telling you that this is not yet in the let's just call it in the library. Let's call it the library. Okay, the library. So let's compile it. So click on make, not compile worksheet, make. Okay, make. So click on make. You can see underneath that same thing that you saw at the beginning of the video. You can also notice that the asterisk has cleared out of all these data types. All these are data types. Okay, as you can see from the folder there, they are data types. For this is for the MP3, task info, ST103, badge totalizer, IO data types, Modbus Master. This is of importance to us, and we're going to see it very soon. We have for HART, we have for EGA, Ethernet IP, serial data types. So keep our eyes peeled. Okay. So the next is to create a POU. Now, a default POU has already been created for us. So I would we'll delete this POU, okay, and create our own POU. So it seems our code is about to complete compilation. Let's see. Hopefully there are no errors. All right, good. We only have one warning. What's that warning? Worksheet empty. Okay, that's because our default POU is empty. So we create our own POU. Well, let's delete this. You can choose to leave it if you want to leave it that way, but just for me, just for naming and clarity in our program arrangement, I would delete it and create my own POU. Okay, so I'll right click on logical POUs, insert program. So I'll call my program Modbus TCP Master. Type is program, which we did before. Language, we have instruction list, structured test, sequential function charts, function block diagram, and ladder. We are working with function block, and you will see why that is the case. So you click OK, and that POU will be created for you. Yes. So our next interest would be tasks. The previous tutorial explained what tasks is about. So it's about telling the PLC which of the POU should be run and which one should not be run. And you can give the task different numbers or like serial numbers. You have 0, 1, 2, 3, something like that. So delete this. We don't have the default POU anymore, so it's useless. So we have to create a new task. Delete this. That task will be deleted. So we right click on it again, create a new task. Okay, you can just give it a name, Modbus TCP. Okay, task type cyclic. Okay, cyclic. I don't know what cyclic means. Okay, but in case you don't know what cyclic means, just give me a minute. I will explain what it is. Click OK, and that task will be created. The interval is 100 milliseconds. Now, we have to be careful about this. If you write a very large program that will take more than 100 milliseconds to complete, you have a watchdog timer error. Okay, so you have to be careful to know the kind of program you're running. And then this is priority 0, which will be the highest priority in the program. So if I give it a 1 to be the lowest, so if I give it a 1 and create another POU and give it a 0, the POU will run first. Okay, I can also enable watchdog. I can disable it to whichever one. Click OK. Okay, so that's task has been created. Now I have to create an instance, okay, of a program instance. So what it means is What the program instance means is where would the with this task that's created, which POU should it be pointing to? What should the PLC run exactly? So click on program instance. You can give it a name. You can still give it a name Modbus TCP. You can give it a master. Okay, and we have this. This naming is such that when somebody else is reading the program, he knows exactly what this task is supposed to do. If you use vague names, it can cause confusion. Make sure to use clear names. You click OK. The program type, you only have the Modbus TCP Master. If we have other POUs here, you will see it in this drop down. You click OK. So now that task has been created for us. So what it means now, when this program is downloaded into the PLC, it will run this program. Okay. Now, the next on our agenda now is to create our data types. But first of all, I want us to look at something. After we inserted the library, all right, there's this toolbar on the right that provides all the blocks, the function blocks that we need to use. Remember I said we're going to use function blocks. So all these are function blocks. The addition function block, bitwise and counter down. And if you select this, click on this drop down button, you see the different function blocks or different libraries that are open for us. So our interest is Modbus. So click on Modbus and we'll see the different function blocks that are available for Modbus. We have this MBRDC, which is Modbus read coil, single coil, MBRDDI, Modbus read digital input, discrete input or digital input, Modbus read RDHR, that is Modbus read single holding register, MBRDIR, Modbus read single input register. Then you have MBRDMC, multiple coil, if you want to read more than one coil, more than one coil. You want to read more than one discrete input rather. You want to read more than one holding registers. That's what this M stands for, multiple input registers. You can also write single coil, write single holding register, or write multiple coil, write multiple holding register. Our interest now is to read multiple holding register. Okay. So now before we do that, remember I talked about the Modbus data types. Okay, now from the name we gave our project, we say Modbus TCP. So that means we are doing a Modbus TCP communication. Okay, so we need to look at data type of Modbus master. Okay, if you click on this, you can see the structure. Okay, you have the structure here, which is for COM. All this COM means is for serial structure output for Modbus master function block, serial communication. You can see the different parameters there. You have the slave ID, which is an unsigned int, port number, which is also an unsigned int, retries, unsigned int, timeout, unsigned double int. You have also this for structure output for Modbus master function block Ethernet communication. So you can see this MB config info ETH. You have this slave ID, port number, retries, timeout, C port number, IP address. Now we are going to create these variables, okay, in the variable table of our POU. Okay, create variables. So this is the first thing we're going to do: create these variables and assign it or link it up with this struct. So this is what we're going to do. First of all, we click on in our POU, we go to this this tab here. Okay, don't click on it, and we are brought to this page. Okay, this is a POU page. So we're going to create a new variable group, and you say insert group. Okay, we'll give that group connection details. Connection. Sorry. Create connection details. You can delete these defaults. We don't need the defaults. Now, why connection details? These data types that you can see here is what will enable the RTU connect with the slave device, all right, using these parameters. We know that the slave ID, right? We know that we're using the the RTU as a master. Okay, so that means whatever device is next to it will going to be a slave. So we're going to give it a slave ID, port number, retries, timeouts, TCP port number, and the IP address. Okay, where these parameters we are going to add it there. Now this is not editable. Okay, like you see, it's read only, so we cannot add any value here. So there's another way which we can do it. So I'm going to show you. So let's create those variables. Now the first is MB slave ID. So let's come here. So let's create that. This is just like Excel. We are going to create like 5. So let's do that. 2, 3. Let's copy all these 3. Insert 4. Thought that was going to work. And 5. So we have 5. Confirm that there are about 6 of them. Let's go to the last one, 6. So the first variable of interest is MB slave ID. So let's give it MB slave ID, and our data type is an unsigned int. Okay, so next of interest is port number. So let's give it port number. Is also an unsigned int, not using retries, and is also an int, and timeouts. Give it udints ints TCP port number, TCP port, sorry, ints. This is IP address, and this one is the variable string, data type string, not variable string. Okay, we'll leave the usage in var, which is local variable, which can be accessed only by the whatever blocks you put in this POU. So we're going to give it an initial value. Modbus slave ID will give it 1. So let's imagine a slave will be giving the ID of 1. All right, the next one, port number. Okay, what do you mean by port number? Remember when we're doing the configuration in the first page, let's go back there. We configure the Ethernet ports, and we are saying we're going to use Ethernet port 1. All right, so that port number is going to be port 1, so that the controller knows that it is using port 1 for the communication. We have already set port 1 as what? Modbus TCP Master. So port number 1, port number 1, number of retries. So what number of retries does is once there's a message from the master and there's no feedback, it does the second one and does the third one, and it brings up an alarm. So give that one 3. Timeouts will be about 300 milliseconds, about 0.3 seconds. TCP port number, that is for Modbus TCP, that will be 502, and IP address, if I assign it as a string, we just give it 192, that's of our slave device, dot 168.10.3. Okay, so that's that for that. So we'll save this. So now we need to, remember I said with these values now that we've assigned, we need to link it up with these guys. Okay, these ones here, so that when the configuration comes, they will know that, okay, slave ID is 1, port number is 1, retries is 3, timeout is 300, TCP port number is 502, IP address is 10.3. So we'll come to our POU page, the page of the application, and then we'll start doing this. First of all, we call our slave ID MB slave ID. Okay, and then there's one thing we have not done yet. So there's one more variable we need to add. and I will explain why we add it. So just insert new variable and call it just a connection to slave one. Okay, I will give it data type config. It's going to be a very global variable. So let's call it variable external. I'll call it config. Hopefully that works. Okay, I don't think that is going to work. No. So what we're going to do is let's delete this. Okay. Save. And then we'll go to our global variables. Under common variables, we'll give that connection to slave one. I'll give it okay. Apologies. So just so we need to insert the block. That's why it's not coming out. It does not exist yet. So we need to insert the block for the Modbus block. Okay. So let's create a new before we insert this. Let's create a new variable group. That's group. No, not that. Sorry. You can insert this here under connection details. So you click OK. Okay, now that we've done that, if you check in here, you can see it. So this is and then when we try to add that connection to slave, let's call it connection to slave one. Call this. I think I'm calling the wrong data type. Just let me check here. I'll see. Yes, I'm calling the wrong name. So that would be MB. Yes, I was calling the wrong name. Sorry about that. Oh, Ethernet. Okay, I would explain that. So, okay, I already explained that before. Okay, this is the data that have been created. Okay, for Ethernet, and these are the parameters. These are the parameters. So now the next thing for us to do, like I was saying before, so let's connect all these parameters. Slave ID. The next one is port number. Pardon. Port number. Okay. Next is I think is retries. Yes, retries. Retries followed by timeouts, followed by TCP port number, followed by IP address. Okay, let's move this fill out of the way. So now on this point, we're going to call connection to slave one dot use a dot notation to call those values, all right, those parameters. Okay, now because of we said that we're using ETH one, that's why this is what is coming. If we used com, another thing would come out. The parameters for com will come out. So for slave ID, we will tell it that okay, the value in slave ID, all right, this 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 information we put here, transfer it to here. Okay, transfer it to here. So anytime the PLC is checking, the VRT is running, it knows that yes, this value is already inside here. One. Okay. The next we have on our table is again we do connection to slave one dot port number. Okay. Then we do the third one, connection to slave dot retries. Then the next would be connection to slave one dot timeouts. Let's go to connection to slave one dot TCP port number, and then yeah, connection to slave one dot IP address. So we have everything now. Okay. So the next thing we'll now do is link it up. This one, two, oops, two, three, four, five, six. Right, make sure this is done first so that when this block starts running, I'll explain when we get to the block. So now on the block now, we also need to now configure it. So we have these various pins. We have the enable pin. If we right click, let's double click on this guy. No, not double click. Here, if we double click on it, you can see the different pins and what they mean. Okay, so the enable pin is a boolean. Okay, either yes or no. So what the enable pin does is that if it's true, this block will start running. If it's false, the block will stop. Config info is this stuff we just did up here. All right, I will show you the data type. Start address, that's the slave device, the first address where is it located. Is it located in 10? Is it located in 20? That's what it will be. Then the length is the total number of data we want to collect. For our case, we are going to collect 50. We are going to collect 50 data. We are going to collect data from 50 data points. Okay. Then endian mode. So for the endian mode, we have different endians. We have the big endian, we have the little endian. Like for 32 and 64 bits, we have the send flag and ready flag. Then we have the done bits, right, which confirms that yes, that communication has been completed. We have the error flag that tells us there's an error. Protocol error that tells us that there's an error in the communication protocol. All right, and it will give us an error code. There is a documentation that shows us the different error code. We have the general error and outputs, if any. I don't think, yeah, this output here. So now for this output is where our data will be stored. All right, remember that data type we created here, the Modbus data storage. Let's just keep it in mind. So let's create this various data type. Okay. So now let's start with enable. So we can give it the variable name enable and set it to true, initial value to true. You can attach this to something, any other thing, maybe like a bit that will come true whenever the controller starts. But for now, let's leave it as true. Before we do this, let's create a new variable group. So come here, right? Come on this, right click this, insert group. Okay, this Modbus communication block variables. Okay, so let's go back to our block. Double click on this enable pin. Now you can see what this one I just created is here. This one is just for clarity in reading, so that you don't have a jumble of variables everywhere. It will be easy for you to read, to know exactly where, when you are troubleshooting, which points to look at. Okay, to keep your code neat, both for yourself and whoever is going to read. So click on Modbus blocks, give it the name enable. Prefer to give it the name that is already on the block. Set it to true, we said, and click OK. For config info, we have already given this a name. So yeah, so you can see this, we've created this variable already. Okay, so you click OK. All right, for outputs, now what name are we going to give this? Now before I give it a name, so let's go back to our Modbus data storage. Okay, we already have this name here. We give it this variable, this data type called data outputs. Okay, data outputs. So what you do is on the outputs, you can just give it the name data outputs, and then we can give it the variable. oh yeah, data output. Okay, you can store it as a local variable, you can store it as a global variable. So it's here. Start address. So I'll call it start address. We can give it an initial value of 1. Let's assume that the slave device, the first data we're reading is on 1. Okay, and this is an uint. Okay, okay. For length, we've already said it's 50 we want to read. So let's give it the value 50. Click OK. So for endian mode, what is the endian mode? Now let's see what this configuration for this block is. So we right click on the block, click help on FBFU. So this would give you the documentation of Honeywell, okay, that explains what that is. So for endian mode, which is an unsigned int, endian mode is required for reading or writing 32 bits and 64-bit variables. As Modbus always use big endian to transmit data, there is no need to set the endian mode for 16-bit data. Okay. So if you are collecting 16-bit data, by default, Modbus uses big endian. Okay. So big endian. But if you are getting more than that, for example, you want to collect 32-bit data, you now have to select one of these. For one, for little endian mode for 32-bit data. Two, for byte swapped little endian mode for 32-bit data. Three, big endian mode for 32-bit data. So what's the difference between big endian and little endian? So so each devices have the way they send data. Okay, some devices send as big endian, some devices send as little endian. All right, so big endian means that, all right, now you're sending 16 bits of data. Okay, the most significant bit will be the 16th bit, and the least significant bit will be the zeroth. We use that term, the zeroth bits. Okay, so when that data is being transferred for big endian mode, it's going to come in that sequence. All right, so let's imagine the data is 1 2 3 4, 0 times 1 2 3 4 in the hexadecimal. So the data is going to come as 0 times 1 2 3 4 in the sequential manner. That's the big endian mode. So if your pressure is about 64 degrees Celsius in the hexadecimal mode, with big endian, it will come exactly like that 64 bit. But in little endian, it's going to be swapped. Okay, what it means is that instead of coming as 0 times 1 2 3 4, for example, it will come as 0 times 4 3 2 1. So that's the at least the basics for the difference between big endian and little endian. Okay, so for our case, we are collecting 32-bit data, which is 2 registers. So we're going to select 3, which is big endian for 32-bit data. So let's go back to our block. Okay, endian mode. So let's double click here, give it endian mode, and we say we're going to select 3 as our initial value. Click OK. Click OK. Then send flag. Okay, now for this send flag, what this send flag will be connected to this ready flag. So what this one does is that whenever this block has completed one communication process, all right, it has sent a request and has gotten a response, this ready flag will return a 1. Okay, now this block needs to know that a communication cycle is complete. So what we will now do is once this guy is 1, it's going to give that feedback to send flag. Okay, now just so we have a little bit of delay, we can put a timer in between these two. But for now, let's leave it like this. Okay, we'll see how when we are monitoring, you're going to see what is here. Now for this done bit, it returns that yes, a communication is complete. So we just give it the name done. We'll not give it any initial value. Click OK. Error flag is also a boolean. If there's an error, it will tell us error flag. We're not giving it an initial value either. Protocol error tells us if there's an error in the protocol. Okay, protocol error. And I will show you in the documentation what the error codes can be. And then you have general error. General error. Okay. Click OK. Now let's look at the. No, this did not. Protocol error. Click OK. Okay. Oh, there's an issue. Yeah. So let's delete this guy. Say protocol error. Click OK. We'll link them together. So it seems like these lines are not supposed to pass any of these guys. Okay, so let's look at what protocol error can be. So we will go back to the documentation. Okay, now let's scroll towards protocol error. Okay, as an assigned is error numbers defined by Modbus protocol. So see Modbus protocol error codes. But before we go there, let's look at general error. This is also a general code. So if we have a 0, okay, when we are monitoring, it means communication succeeded. If we have a 1, input parameter is invalid. 2, response timeout. 3, controller internal timeout. And 4, invalid request. So this code will help us with troubleshooting anytime we are communicating. Then let's look at the Modbus protocol error codes. So if you look at it, we can see the different error codes. Okay, so when we see all this, or when we see a number there, we see all this, we'll know what's exactly the problem and know how to adapt our troubleshooting strategy. So let us come back here. We'll save this. Let's look at our variable table. You can see everything that we have done so far. Okay, our data output, this thing. So now let's create a new group. Okay, a new group, and we'll call this group we'll call it our data storage point. Let's just call it points. Okay, and then let's just insert variable. Control Shift I to insert more. Let's just let me do like 15. Okay, so let's call this pressure. Let's call this material. Let's call this temperature. Let's call this humidity. Let's call this it's also real. Let's call this flow rate. Give it a real. Sorry, I'm not supposed to use space. Flow rates. Okay, this is also a real. Let's call this density. Real. Let's call this total volume. Volume at, just call it at base conditions. Conditions. Valid name. Why? Okay, just call it volume at base. Oh, sorry, no, that's wrong. Let's call it volume at base conditions. It's a real. Let's call this volume at measured. Okay, give it a real. Let's call this pump speed. Okay, can still call this a real. I'll call this valve position. Give this a real. Let's call this let's see or let's call this valve one position. Valve one position. Call this valve two position. Give it a real. Call this valve three position. Call it a real. And then let's say let's call this emergency shutdown valve. Shutdown. Look, no, this is not. We cannot have a real for this. Let's look at um, temperature of let's call this temperature, room temperature. Let's just call it room temperature. Temperature real. Let's just give this. Let's just call it valve. I'll call this fan speed. It's real. We can call this. Let's think. Okay, we can call this voltage. Give it a real. I can call this current. Give it a real. Now you see why I'm doing this. Okay, so let's go back to our block. Now remember this data outputs. We need to when the data output comes, it comes as on the table like in an array. Okay, so we need to assign this to we need to create variables in order to store this data so that when we want to use them, maybe we want to tag them with HMIs on this control edge, we can just pick them, all right, and tag them instead of it to be a lot easier to do that. So we can now do that under here. Okay, we can let's arrange our code. That's just the little downsides with using a function block arrangement of your code. So this is part of the things you need to consider when you're writing code. You have to keep your code neat. Okay, so so if we have more than one of these blocks, all right, we need to keep it a little bit arranged so that our work would be neat. Okay, so let's leave this here. So over here, let me see, over here, you can now create that table. So let's call this data outputs, put it in an array, we'll give it 1, which is our first data point. Okay, and then we'll call it pressure. Pressure. We'll link it up like this. Boom. Do data output 2. Data output 2. We'll call it slash comma right. Nope. Output 2. Let's move this way. Oh, come on, man. See, I'm trying to keep my code neat as possible. I'll give it temperature. Okay, let's put this guy here. Call it temperature. Oh, no. Come on, buddy. Call it temperature. Data output 3. 3. Okay. Okay, let me just arrange this so that I will save more time. 4. Right. So come here. Data output 5. 5. Come here. Sorry, I think I'm making a mistake. First of all, the data I'm pulling is they are real data points and they take 32-bit registers, as you can see here. So that I'm doing is not going to work. So I have to change this to not 2. So this is going to be 3. Okay, this is going to be 3. I hope this would work. Okay, this is going to be 5. This is going to be 5. Okay, this is going to be 7. This is going to be 7, and this is going to be 9. 9. Okay, so let me just copy this and paste. Oops, nope. Control C. So Control space this. Nope. Let's paste this. Let's paste this. Let's paste this. Let's paste this. Good. So we have 11. We have 11. We have 13. 13. This is when we are collecting 32-bit or real. Okay, if we are collecting long real, it will take 64 bits. Okay, that will be 4 registers. So no, that's not 14, that's 15. 15. Let's call this 17. 17. Let's keep this. So this one is real. Okay, 19. Okay, let's arrange them. Okay, let's do this. Let's do this first of all. On our table, the next we have is humidity and flow rates. So, remember that. Let's come here. Call humidity. Next is flow rates. Um, Next is just also work fast. Density and volume at base. Volume at measured. Density. Volume at base. Volume at measured. But, nope, I don't need you. Yeah, that's what I need. Volume at measured. Next is pump speed and the valve positions. So let's do that. Pump speed. Okay, let's do valve positions. We have valve 1 position. We have valve, yeah, valve 1 position, valve 2 position, 2 position, valve 3 position, valve 3. I think I'll starting from valve will make it faster. Valve 3 position. Let's organize this. Okay, let's finish it up. Then we'll arrange the jumble. Room temperature, fan speed, voltage, current. So that's the room temperature, fan speed, and not the speed. Yep. Voltage and current. I think that's everything. I think that's all. Yeah, that's all. Okay, so now let's organize them. Okay, let's bring humidity here. Okay, let's just link it up together. Boom. Okay, and flow rates. Let's bring here. Nope, no, that's not what I intended. Let's come here. Let's link them together. Okay, so this is similar to what we did with the connection parameters. Okay, so that whatever values there will be assigned to this variable. You understand? So that when we're monitoring, you're going to see it. See it work. This might be a lot of work for this project, for this software, uh, but I mean, this is how it is designed. All right, it's necessary to do this. All right. Siemens makes it easy for us. For example, Siemens makes it easy for us where you can just create these variables and then use the PTR as a PTR arguments on the function block. Okay, PTR arguments where you just point it to the data block. So I think that would have made it a lot easier, compared to doing all this. Okay, so let's organize all this so that we'll be fast. It's also important to work fast. Okay, so imagine you are doing this for more than one. Let's imagine for 200 data points. I mean, this is going to be a lot of work. I can't believe this. Yeah, I think Honeywell needs to take into consideration. According to the datasheet, this is how it's going to be done. Not any better way to do it. So let's get this. Yep, let's put this here. Oh wow, I have more than 10 data points here. More than 10. How many do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. See, okay, that's 15. So let's link this guys up first of all. Let's come here. Let's come here. Okay, this guy's not organized. This, oops, not that, not that. Let's come here. Yep. Let's come back up here. Let's link you up. Let's link you up. Okay. Now let's correct some things. So let's say data outputs 21. Okay. Come here. So let's get this done for finish. Data outputs. The outputs 23. Data outputs 25. So data outputs. Man, this is gonna be a lot of work. 27. It is very important that you plan ahead and you are able to work fast so that you do this in a very short time. Okay, it's a very short time because imagine having to do, like I said before, for almost over 200 data points. Wow, you're going to type a lot. Data output 31. 31. Okay, so that's about 15 data points times 2, that's 30. Okay, so let's organize this, guys. Come here, 23, 25, come here, 27, come here, 29, 29, come here, and 31, come here. Okay, so let's bring these guys. Let's see, let's arrange them according to what we have here. Done for 1, 2, 3, 1, 2, 3. Okay, 3. So temperature, fan speed, voltage, temperature. I think I have a repeat. So I have room temperature, fan speed, voltage, currents. Okay, yeah, this seems a bit pressure, temperature, humidity, flow rate, density. Yep, volume at base, volume at measured, pump speed. Ah, I see. Now you come here. Yep, it's here. Pump speed. You took over someone else's position, eh? So you have to be very careful. All right. See this mistake I just made. Pump speed. This is supposed to be valve one position. And then this is valve 2 positions. So you have to be very careful, especially because of your tagging. Valve 2 position. Okay. And, this is supposed to be this. Yeah, just right. Valve position. So yeah, position. I hope I'm recording. This is going to be very painful if I'm not recording. 3 position. Nope. That's not what I intended. 3 position. Yeah, come here. Fan speed. Okay, I did it. I think I did it a bit too much. Oh, I'm surprised. How's 15, 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15. That's 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. Ah, I see. Okay. So probably my numbering is wrong somewhere. 7, 9, 11, 13, 15, 17, 19, 21, 23, 24. Ah, incredible. Okay. Let's keep these guys arranged. So that's the one of the cons with function block. You treat it as though you are doing a design. You have to keep your work as neat as possible. Okay. I love to keep my work neat. I love to keep my workspace neat. I have a bit of a compulsive need to keep things neat. Okay, nope, that's not what I intended. So sorry, ignore the sound if you heard that. So, okay, so I think that is that. Save. Okay, so what happens now is that whatever is in data output 1, okay, from our block, all right, the start address 1 will be inserted into pressure. Okay, so let's save our work, and most importantly, let's compile. So we use the make to compile, and let's hope. Actually, we don't need to hope. It should compile fine. We didn't make any mistake. All the data points are correct, so we shouldn't have a single issue. Okay, just give it some time. So as you can see, all of this are neatly arranged. 1 to 15 data points are accurately arranged. So we can do this similar to serial. If you're doing serial, like I said before, this is the configuration for serial. Okay, slave ID, port number. That's for port number. I will show you. Yes, I'll show you. I think I can actually show it to you. Let's go back here. Let's finish compilation. Yep, no errors. So for the serial, for the port number, it's the same thing. Okay, for like for the ETH. Yeah, I want to save the configuration, please. Okay, just give me a minute. Okay, so for the serial port, it's the same thing. You have RS232 port 1, RS232 port 2, or RS485 port 1, RS485 port 2. So if you're using RS485 port 1, you have to define it as, oh yeah, port 1. Okay, okay, port type RS485. What I'm not 100% sure of is, let me just look at something. Let's look at this fella. Hmm. So this is not a difficult thing. We can easily check the data sheet. So right now our code has finished compiling. So the next video, we'll download this program into the RTU and then we'll see it work. We'll come here, we'll put it on monitoring and we'll see what the values are. For these guys, you see what the values are. For this, you see what the values are. For this, you see what the values are. And if there are any errors, we'll see the error code here. Okay, so the importance of dividing this connection variables, your communication block variables, and your data storage points. When you're troubleshooting it, it's so easy for you to know where to look at. All this are stored in the local variable. Okay, so thank you very much and see you in the next tutorial.